In this video, I'm going to be doing AtCoder beginner contest 158, and I'll be explaining my solutions after I finish off the problems. Okay, there. What? How did I get wrong answer on this? Oh, I missed. I used uppercase. So this is just brute force. Why is this in? Okay, I'll read this first then. P is a prime number. I think we just have different cases for P equals to 2 and P equals to 5. Okay, I'll calculate this starting from the back. Wait. And we maintain powers of 10. F and C. And G. This is the beginning, okay. Okay. I think this is a DP from the right. Then we can just binary search. The exit reaches. Think like this. right. I see. Okay, so do I need a segment tree for this? Maybe I can just use a stack. too slow this time as well. What? Somehow I'm still first now. Okay, I'll just hope I'll still be first at the end of the contest. Actually, a lot of people have penalties, so yeah, I think even though I made this very stupid mistake on A, I'll probably still get a very high rank. Okay, let's look at the solutions. So for problem A, if there is a pair of stations that is connected, and that means that they are from different companies. So we're basically just finding if S contains both A and both B. And you can do that easily with two if statements. You can compare the first character of S with the second character and the second character of S with the third character. But what I chose to do is I chose to sort the string S. So if S contains both A and both B, that means that if S was like this, then after sorting, A would be on the left side and B would be on the right side. So then you just need to see if the first character is the same as the last character, and if they're the same, then that means that we don't have. That means that answer is no, and otherwise it's yes. So for problem B, basically you notice that there's a cycle for the balls that are placed. So each cycle has length A plus B. And each of the cycle basically consists of the first part has A blue balls, and then the second part has B red balls. And then you continue on with this. So since n is very large, what we're going to do is first we'll see how many cycles of A plus B does our row of n balls has. So for n balls, basically the number of full cycles of A plus B, we can just divide n by A plus B to get the number of cycles. Then in each cycle we have A blue balls. So then we multiply this the number of cycles by A. Then at the end of the n balls, maybe this is one cycle, and then maybe it looks like this, and maybe n ends over here. So n ends in the middle of the cycle. And if n ends before the A blue balls ends, then that means our answer is just the remaining part of n, which is part of this cycle, is n mod A plus B. So if n only extends into this part of A balls, then the answer will be the remainder of n divided by A plus B, which is just the part which goes into the cycle. And if n goes into this part instead, then we shouldn't count these balls, since these are red balls. So when that happens, we simply just have this cycle simply just has a balls. So we take the minimum of the remainder of n divided by a plus b and a. For C, once you look at the range of a and b, you notice that they're both pretty small. They're just less than or equal to 100. And then the tax rate, so once your price, so in here, once your price goes over 10 to the power of 4, then your tax rate, which can be, then your tax rate is about $800. So if I test up to I equals to 10 to the 4th, then I'll get this 800. So if I test anything over this, then like it's pretty much useless since A and B are only smaller than 100. So testing the price until 10 to the 4th is definitely enough. So that's what I do here. I just loop through I from 1 to 10 to the 4th. Then I calculate the tax rate for both of them. And if the tax rates match, then I just output the answer. And then if none of these match, then I just output that there's no solution. So for D, the main observation is that if you reverse the string, if you perform this operation 2 times, then it's the same as if you did not perform any operations at all. So if we only had operations of this type, what we would do is we'll keep this boolean which keeps track of the state of the string, and each time we reverse the string, we just modify the state. Then finally, if we find that the state of the string is reversed at the end of the queries, then we'll reverse the string. And this is the case when we only have the queries of type 1. But if we have the queries of type 2, then it's similar as well. So what we can do is, well, if the string isn't reversed at all, then what we can do is we'll keep 2 vectors. The first vector of v of 0 will be the characters which are added to the beginning of the string. And the second vector, which is v of 1, will be the characters which are added to the end of the string. So for each query of type 2, what we do is we just find the corresponding vector, which will be in F, and then we add the character to it. And then once we process all the queries, we go through the characters which are added to the beginning, which is in v of 0, and then we add them in reverse order because the ones which are added last should be first in the string. So we start from the end of the vector and then we go to the front and we add the characters, and then we add the string s, which comes from the input, and then after that we add the strings. We add the characters which are added to the end of the string, and they should just be added in the normal order because the characters which are added first, they will appear first in our final string. And then finally, if we want to support both of these queries, we'll just use some combination of the tricks we use. So when we process queries of type 2, notice that I have this XOR state over here. So basically, if this current string is reversed, then this will be equal to true. That means that F will be flipped. And that makes sense because our current string T will look like this when it's it'll look like this when it's not reversed. After we reverse it, we have our characters in the back first, and then we have our characters in the front. So when the string is reversed, if we want to add a character to the beginning, then we're actually adding it to the back. So that's why I flip it. And then when this also, if we want to add a character to the end, we're actually adding to the vector front. So in both cases, we need to, when the string is reversed, we need to flip F. And finally, the last part is just completely the same. So first we add all the characters in our vectors, and then we reverse if the final state of the string is reversed. Okay, for E. So first, we need to process the prime numbers 2 and 5 individually, because 2 and 5 are divisible by 10. So so we can determine their divisibility just by looking at the last digit. So if P is equal to 2, then let's suppose that I is the last digit in our chosen subarray. Then if S of I is even, if the ith digit is even, then that means that we can have a subarray which ends at I, and there are a total of I plus 1 subarrays which end at I. And then for the case for when the prime is 5, we also have a similar solution here. So if the digit at I is 0 or 5, then that means that the subarray can end at I. So we also add I plus 1 to the answer. And otherwise, P is not, P is co-prime, but P will be co-prime with 10. So we can notice something. So say X is our number, and so P will divide X. Okay, so given that the GCD of P and 10 is equal to 1, P will divide X. This condition is equivalent to P times 10 to the I will divide X for any I greater than or equal to 0. Wait, I messed this up. Wait, so P will divide X times 10 to the I for any I greater than or equal to 0. And this is true because this 10 to the, since 10 to the I does not have any factors of P, it means that multiplying this by 10 to the I won't affect the divisibility of X by P in any way. So given that this is true, what we can do is, in the example here, so when we check this substring 3, what we do is we actually check this substring, and then also, so instead of writing the substrings like shown in the sample test case here, we can consider the numbers to be padded with powers of 10. So we basically, it kind of just, the digits are there according to the original positions in the array. And this is useful because each subarray like this, we can write it as the difference of two suffixes. So for example, for this subarray, we can write it as the difference of this suffix, which is just the entire number, minus this suffix. And then, for example, this subarray, we can write it as the difference of, we can write it as the difference of these two suffixes. And then this will just be 0 will also count as a suffix. So what we're trying to do is this is suffix of 0 and this is suffix 1. Trying to find the number of pairs ij such that I is smaller than j, and also suffix of 0 minus suffix of 1 is congruent to 0 modulo p. So this means that this is divisible by p. And this condition, and this condition is just, if we move suffix of j to the right side, we end up with this condition. So what we'll do is we'll calculate all of these values mod p, then we'll store them in a map, and then this should be a pretty standard problem. We'll just calculate these values mod p, and then we'll store them in a map while we iterate from right to left. Okay, so in the code over here, basically for the empty suffix, the value will just be 0, so we add 1 to that, and then t will be the value of the suffix, and then p2 will be the power of 10 corresponding to the ith digit. So each time we go from right to left by 1 digit, our power of 10 increases by 1. And then in order to calculate the suffix, we basically just add the ith digit. So we take the value of the ith digit and then we multiply it by the power of 10. And then we take it modulo p. And then we find, so if we suppose that the current I is the I in here, then in order to find the number of j with the same remainder mod p, we basically just take the value of the map at t, and then we just add 1, we increment the value of increment 1 to map of t, so that in the future, if there's other I which query this value of t, then this I can be considered as one of the j. And we just iterate this from right to left. And then, we just output the answer. Okay, so first I'll explain why this is DP, why this problem can be solved with DP, and then I'll explain how you can optimize it using a data structure like a segment tree or a stack. So first of all, when we activate a robot, so let's say we activate a robot here and it goes here. On the way, it might activate some other robots and it might look like this, but in any case, we'll activate a continuous range of robots. And after that, all of the robots on the right side will not be affected. So let's say this is I and then this is j. And let's say that dp of I is, by the way, we sort the robots by their x coordinates first. So dp of I is the number of ways considering a subset considering the suffix starting from index I. So there are two cases. You can choose to not activate. We don't activate I, then we basically just ignore. We just ignore I, and then our answer will be dp of I plus 1. But then if we activate I, then our answer will be dp of j, where j is the first robot that will not be activated if we activate I. So if we add that together, we get dp of I is equal to dp of I plus 1 plus dp of j. Then the base case is dp of n when, so the suffix of n has no robots. So in that case, the only possible set is the empty set. So the answer is 1. Okay, so that's basically what I do in my code here. So I calculate p. The p in my code is just the j here, and yeah, basically I add up dp of p with dp of I plus 1, and that'll be my dp of I, and the final answer is dp of 0. So now let me explain how you can optimize this. So what I did was I maintained a stack. So at first the stack has an element at position n, and then I also have other elements here, so maybe x1. Then this element means that if I activate the robot at x1, then it'll activate all the robots until n. Then I have x2, which means if I activate robot x2, then it'll activate all robots until x1, then so on. So how do I... So the first thing, okay, so first we need to find what p is. So let's just say that we have these elements in the stack. And then let's say that if our robot and our current robot is here, and if we activate it, let's consider the first case when it just goes here. And since this is to the right of x of 2, that means it will also activate x of 2. So that means that this entire I, along with this group of robots, this will be activated. So we should merge these two groups together into one. But then if I goes even further, that means that this group x2 will be activated and this group x1 will also be activated. So we need to merge all of these together. So basically what we do is this will be the top of the stack, and then we check the amount that our current robot can reach to. So, and if the current robot can reach the top of the stack, then we merge the top of the stack with our current robot. So basically we just remove it from the stack. And then let's say that once we finish that, let's say I goes here, so we move the group x of 2. So now this is the new group. The new group is now I, and it's the next one is x of 1. So p over here will just be the next robot in our stack. So it'll be on the top of the stack when we remove all the robots that I can reach. So I set p equal to the index of the robot of the top of the stack. Then I add the group I to the stack. So first I add the index of the robot, and then I add the position of the robot. Yeah, and that's basically how I update the stack. I know that this solution, except for the sort, it works in linear time, but there are also other solutions. So you can store the, for example, if you wanted to use a segment tree, you can store for each robot how much distance it moves to the right, and then in order to find the distance that you can affect with a new robot, you just need to do a range maximum query, and then you also need point updates to update the distance, the number of robots you can reach for your current robot. And then you do the same sweep from right to left. Yeah, so that's basically it. I know that I had limited time, so I wasn't able to go over everything in a lot of detail. So if you have any additional questions, please ask them in the comment section below. And if you like this video, then you can press like under the video, and you can also subscribe. And yeah, thanks for watching.